How about calculating a straight line through 2 points? This is comparable to the exercise of the so-called 2-point form. I also have a video on that. And the principle is you have 2 points and you have to find out about the directional vector, the connecting vector between those 2 points. And then you take this directional vector and one of those 2 support vectors you have been given, so that's one of those 2 points, and put it together and you end up with the definition of a straight line. So in principle, I also have a small picture for you, as you can see here. So we have a coordinate system with x-axis, y-axis, 2 points, A and B. And you already see when we connect them, we will end up with a directional vector or connecting vector. So it goes from A to B. And then we put all this information in the representation, in the special expression for straight lines, and then we end up with the result. So not too complicated, and I will also demonstrate it to you with an example. So have fun with the following video. How to calculate a straight line through 2 points. It is actually very easy if you know how to calculate a connecting vector. So let's just see how it works with an example. We have given 2 points. One is A, minus 8, 10, minus 4. The other one is B, 6, minus 2, and 3. So this we call this vector A, and this we call vector B. So these are support vectors. And first step, we need to calculate a connecting vector. Calculate the connecting vector, which can be actually, there are 2 ways how to calculate it. So I say V1 is B minus A, and V2 is A minus B. And maybe you may already know it. There are, for this type of exercise, there are 4 different solutions, or there are many solutions actually. There are many, actually infinite ways how to express a straight line. But usually there are 4 solutions to this kind of exercise. So I'm going to show you why. So we have 2 points, A and B. Let's assume they look like this. Our coordinate system. And now what we can calculate. There are 2 ways to calculate the connecting vector. We can say, okay, we say this line would be A and B, and we say B minus A. This would be B minus A, but we could also say A minus B. Then we would end up with this one. So there are 2 solutions, 2 obvious solutions for the directional vector. And there are also, because it's already given, there are 2 support vectors, which are A and B. So this points, the arrow goes to B. Right, this is support vector B, support vector A. And for a straight line, we need 2 things. We need 1 connecting vector and 1 support vector. So this is the direction vector, and 1 support vector. Then you see there are 2 connecting vectors, 2 directional vectors and 2 support vectors. When we have twice 2 possibilities, then we end up with 4 possible solutions, 4 possible obvious solutions to this type of exercise. So we can actually choose what we want to calculate. But in this case, I take V1 and I say V is, oh, V1 doesn't really matter, B, which is 6 minus 2, 3. And we subtract A, which is minus 8, 10 minus 4. We end up with 14 minus 12, and 3 plus 4 is 7. So now we know the connecting vector, and this is the directional vector. Then what else we need? Then we are actually already done. We can write down the straight line between those 2 points. Now we can choose. Either point is fine. And just I choose A, and I say 8 minus 8. Oh, let's try it again. G is minus 8, 10 minus 4, plus R. This is just some number, some random number, whatever you like it to be. 14 minus 12, 7, and R is element R. It's like with linear functions, you always have some variable, and the variable is element R. So as you can see, it is not too difficult. You just have to keep in mind there are 4 obvious possibilities. There are way more possibilities. Of course, I could also change this vector or take the same direction and make it a little bit shorter or make it longer. There are actually, I told you before, there are infinite ways how to express a straight line, but when you have given 2 points, there are 4 obvious ways how to describe a straight line through those 2 points. So 2 possible directional vectors and 2 possible support vectors. The support vectors are the points, and directional vectors can either be from B to A, or this is from B to A actually, and from A to B. And in this case, I chose the first one, B minus A, and I end up with this directional vector. I just put it into this equation in this expression to show the straight line. So it's not too difficult, actually quite easy, and maybe you need a little bit of practice, and that's how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.